Thanks, Benny. Thanks everybody for joining. As Benny mentioned, my name's Shaun Finn. I'm a Retrofit Energy Engineer with Electric Ireland Superhomes. Today we're going to talk about retrofit management, and part of that is the initial assessment, the measure selection, and the cost benefit analysis. So a little bit about that as well. The next one, so a bit about ourselves as a company. So Electric Ireland Superhomes stemmed as a joint venture from Tipperary Energy Agency originally, who had the Superhomes as a one-stop shop model as part of their branch, I suppose, of that sector. And then we joined with Electric Ireland Superhomes, which are obviously, one of the largest utility providers, 1.2 million retail customers across Ireland and the UK, and their focus was trying to get into or focus on clean energy and decarbonising heat. And we've joined together to create Electric Ireland Superhomes, and our target is to retrofit 35,000 homes by 2030, in line with the government's climate action plan. So another bit about us is, look, Electric Ireland Superhomes is Ireland's leading home retrofit one-stop shop, committed to guiding Irish homeowners to a warmer, comfortable, healthier, lower carbon home while helping Ireland achieve its 2030 climate action targets. We believe that the best way and the only way to a great B2 building energy rating is through a whole house retrofit powered by a renewable energy or a heat pump, essentially. You'll see here in the graph to the right hand side that's our plans for the future. So 2021, I think we completed 105 homes. 2022, the aim is 250, and 600, 1250, and it goes on from there to achieve that 35,000 homes by 2030. So what is a retrofit one-stop shop? Essentially, it's taking care of the process end to end. So we're consumer education and support. So our retrofit advisors would be contacting homeowners and okay, sorry, apologies. Sorry, Is that sharing now? Sorry, apologies about that. Apologies about that now, I didn't realize that it wasn't screen sharing. I'm having a bit of trouble on my end with being able to hear and muting. So yeah, these are the slides we've been through in relation to the initial assessment and introduction. That was the slides in relation to introducing ourselves and the joint venture between Tipperary Energy Agency and Electric Ireland to form Electric Ireland Superhomes. This was a slide, sorry, I'm just trying to do a bit of a catch up now, in relation to our targets, so what we're trying to achieve there, which is 30,000 homes by 2030. And then we were on to this slide when I realized where we were. So what is a retrofit one-stop shop? We're in charge of the process end to end for the client. So from the beginning right through to handover. So your consumer education and support, which would be the retrofit advisors, who would be dealing with the homeowner to begin with. You then have the home survey, retrofit design and tender, contractor selection and project management, and quality assurance, which would be dealt with by individual engineers for each project. You also have the management of the SEAI grant funding and help in secure and affordable finance. So it's an overall one-stop shop. What is a superhome? So a superhome combines a range of the most energy efficient measures to achieve B2V air rating or better, creating a warm, comfortable and draft-free home free of fossil fuel heating. So it generally tends to be a heat pump. You have insulation, you have advanced ventilation, hot water on demand through heat pump, which is always prioritized, solar PV, high performance windows and doors, air to water heat pump, and air tightness generally, as a quick overview. We also have Heat Pump Plus, which is it's generally for newer houses that have already completed many fabric upgrades, usually 2000 to 2011, kind of C2 to B3 energy rating to begin with. These are homes that already meet the heat pump standard or are very close to it. And these projects only require a heat pump and usually a couple of fabric measures, which might be attic insulation, cavity wall insulation, something kind of those cost-effective upgrades. And they have a far shorter lead time in terms of products and not having to wait on things like windows, etc. And they have a shorter on-site install time. So in relation to initial assessment or the home energy survey, we carry a room by room survey of the property. Usually takes 2 to 4 hours on site. We speak to the client to begin with. We speak to the client and ask about any particular problem areas that they might know about. Obviously, from living in the house, this might be mold or damp buildup. It might be in a certain room, a particular room that's colder than others, a particular room that's draftier than others, just so we can get a feel for the building. We look around outside then first, take photos of items such as the roof overhangs, soffit or tile vents inside meter box if there is one, so we can get an idea of what type of construction there is there, whether we'll need to include roof ventilation further down the line, and get photo evidence of all those things. We'll sketch the property, each floor, room by room, measure each room, as well as measure each window and take note of its type, each radiator, take note of its type, take notes on vents, fans, open fires, stoves, boilers, type, make and model, cylinder, whether it's insulated, what kind of controls are there, showers, and even bulb types are some of the things we have to note on each survey. Take note of any insulation and measure it if possible. Some obviously are inaccessible, some are fine. The type of construction, and we try to take photos of everything as much as possible for evidence. So we also take note of heating controls. So whether it's thermostats, TRVs, or thermostatic radiator valves that just control temperature, thermostats that might have time and temperature control, whether it's zoned, which will all make a big difference to the existing rating to begin with and what we install or propose going forward, as well as the type and condition of the heating distribution pipework. So whether it's a micro bore, whether it's gun barrel pipework, whether it's copper, PEX pipework, etc., will all make a difference in what we recommend, whether it needs to be repiped, etc. And we also discuss the findings with the client and give an overview of the process going forward. So we'll let them know what we found on our survey as we've gone through, and discuss what the next steps will be going forward. Some of the tools required for a survey. So you have, obviously it's a lot of data gathering. So you have the DEEP or SEAI's home survey form that you can download online, and anybody is available. You have variations of that form, which different people use and have adjusted to suit their own kind of survey needs. You have taken down radiators, so you're looking at location, reference, the height, width, panels, so how many panels and how many fins it has. It gives you an idea of what kind of we'll let you know what kind of output that radiator is going to give when we go and do room by room heat loss calculations further down the line. And then some of the tools you use, fairly basic in terms of laser measure, for room by room widths, heights, tape measure for measuring radiators, graph pad for sketching out the whole building, and then the one in the middle there is a moisture meter, which allows you to measure the moisture in the timbers and the roof. Part of the reason we do that is for if there's a property that has, say, 100 mil or more attic insulation to begin with, and there's no sign of mold or damp issues or any kind of moisture buildup in the loft, and you can measure the timbers and ensure that they're not too high in terms of moisture, then you don't have to specify additional roof ventilation for that property. And then the other one is a meter box key, which you need to access those areas. So some of the retrofit measures which we carry out and specify would be fabric, which could be walls, it could be external, internal, or cavity wall insulation, depending on obviously the construction of the building and what suits. Roofs, you have attic insulation, sloping ceiling insulation, flat roof insulation. Floors sometimes are done. We wouldn't generally recommend digging up existing solid floors. It just doesn't really make sense in terms of it's not cost optimum, and it takes a lot of work. It's very laborious, but we do have clients that wish to go ahead and install underfloor heating, or for other reasons, they might have rising damp or old floors that need replacing, that they do it for. You have windows and doors, which sometimes again need replacing, more often than not, and sometimes you can find without replacing them, they're in reasonable condition or they've been upgraded previously or recently enough. You have air tightness, which we always recommend to our clients as best practice. So trying to address them areas of air leakage where possible. Ventilation, which comes along with air tightness. If you're doing air tightness measures, then you should be recommending ventilation as standard. Ventilation is key, I suppose, to a healthy indoor air quality, and it's a purposeful air infiltration, I suppose, rather than the what you're trying to do with the air tightness, which is seal them unwanted air leakage paths. You have the heat pump, which includes your heat pump cylinder, changing radiators, potentially installing underfloor heating. You also have solar PV, which is an optional. In most cases, you can reach the B2 rating that's required without having to install PV, but sometimes it just makes sense, and other times clients request it, so it's included as an option in most scenarios. Measure selection then. So how we go about selecting these measures is it will depend on the type of construction, the budget the client has, what best suits the property, and what best suits the client. So we have to try and achieve, for the scheme, you have to achieve a heat loss indicator of below 2, ideally, or a HLI between 2 and 2.3, where backstop U values can be achieved. These backstop U values would be 0.37 for walls, generally 0.25 for any inaccessible roofs, which would be sloping ceilings, flat roofs, and 0.16 for any accessible or attic area, and then also 2.8 for a U value of 2.8 for windows, which can be achieved with a most reasonable standard of windows, and then also a backstop for air tightness, so 0.5 air changes. You have to meet a minimum of a B2 building energy rating and a 100 kilowatt hour uplift in the building energy rating. So that's the kilowatt hours per square meter per year in terms of its measured energy through the building energy rating, and that has to be achieved for the one-stop shop model. We tend to start with the most cost-effective upgrades and work our way down until our requirements are achieved for the scheme, and also, of course, what makes sense for the client and for the property. And we put all of this into a home energy report, which is easily readable for the client. You'll see to the right-hand side here that we have the HLI table, heat loss indicator table. So this is something that we include in our energy reports, which shows the client what measures we're recommending, an overview of what measures we're recommending and what effect they have on the HLI and the BER rating, or the kilowatt hour uplift. So you'll see there, attic insulation in this scenario has a reasonable effect. 0.37 on the HLI improvement. Cavity wall insulation has a very large improvement in this scenario, which is because it was a totally uninsulated empty cavity, and a good improvement on the HLI there. Triple glazed windows were specified. They were single glazed windows at the time. Low energy door, so front and rear door, and the air to water heat pump. We also, as I said, recommended air tightness and demand control ventilation as standard and as best practice. And then we had an option then for external wall insulation, which was at the client's request. We could meet the requirements without doing external wall insulation. The client wished for an option for external wall insulation. You'll see there in this HLI table and in this scenario that it didn't have a huge improvement on the heat loss indicator or the kilowatt hour uplift. So for the cost that it was going to be, which was in the region of 25,000, it wasn't, you weren't seeing a huge improvement. The client in this scenario did actually go ahead with the external wall insulation, and that was just through personal preference and wanted the additional comfort. So the cost considerations in relation to retrofit. So the cost of retrofit depends on lots of factors, mainly the size and age of the house, the wall types, the measures that have already been completed before. So some homeowners have already done certain measures over a certain period of time. And this all has effects on what the cost of the retrofit overall is going to be. So if you have a very large house that's G rated, you're going to end up spending obviously more money on that property, but it's also going to have a lot more benefit than somebody that's already maybe at the C rated level, we'll say. The cost range we tend to find on average is 40 to 80,000, and that range is there because of those variances in size, type of house, and where it is to begin with in terms of its energy efficiency. And then the net costs after the grant are in the region of 24,000 to 48,000. So the grants are substantial this year in line with the new one-stop shop scheme, and the SEAI grants are fixed per measure and per house type. We advise unexpected costs and SEAI grants available in our free initial consultation, which will be done by a retrofit advisor. So when a homeowner makes their application online, our retrofit advisors get in touch with them and go through all of these potential scenarios, what the estimated cost would be, and what they're looking for. The one-stop shop grants, SEAI's grants, the grant funding scheme there. So we've created a table here, which is cavity wall insulation is offered in the range from 700 to 1700. This is based on the range from it being an apartment, mid-terrace, semi-detached and detached, with an apartment being 700 and detached being 1700. And it fluctuates in that way for most measures. So external wall insulation, 3,000 to 8,000. Internal wall insulation, 15,000 to 1,500 to 4.5. Sorry. Attic insulation or ceiling insulation, 800 to 1,500. Rafter or flat roof insulation, 1,500 to 3,000, and so on. You can see there as it goes along. Windows and doors, external doors, 800 to 1,600. So it's 800 per door with a maximum of 2 doors allowable under the scheme. Floor insulation is a 3,500 flat fee, regardless of what house type. Air tightness, 1,000. Mechanical ventilation, 1,500. Air to water heat pump is 4.5 to 6.5. You have air to air also, which is 3,500. And then you've solar PV, which is 900 to 2,400. That's based on 900 per kilowatt for the first 2 kilowatts and 300 per kilowatt for each kilowatt after that, up to a maximum of 4 kilowatts. We can, there is higher grants that can be approved for housing bodies and multiples, and we do offer that service in terms of we can offer multiple houses under one kind of scheme, I suppose, for housing bodies or something similar. And then there's also single measures grants available, which are through the kind of BEH. So there's also another additional grant that's available through the one-stop shop model would be the one-stop shop bonus, which is €2,000, and that's for meeting a B2 minimum with a heat pump. So that's a bonus that's available there for that scenario. Other stages in the retrofit journey are that we carry out, and I would as an engineer would be room by room heat loss calculations. So once we've established that we've done the room by room survey, that gives us everything we need to do the room by room heat loss calculations and the heat design for the project or for the heat pump that's going to be installed. We tender the project to approved contractors. A homeowner can bring on their own contractor once they're approved, which is kind of a consultancy type role that we take on, and we work with professionals and architects and engineers in that role. And we also have the heat pump plus scenario, which we talked about a bit earlier. We evaluate the tender against current market rates. So just to make sure that the client is getting value for money. And then we also, everything goes into the home energy report. Once the client receives that, we arrange a consultation with the engineer and the retrofit advisor to go through the entire report in detail. We also, once a client agrees that they would like to go ahead with the tender and the grant offer that's there, we draw up contracts. So firstly, we get the grant approved by SEAI, so we make the grant application to SEAI, get that approved, and then we draw up and issue contracts, which would include a detailed scope of works, start and finish dates, payment schedules, all that information that the client and contractor need to know. We then move on to the project management side of it, which would be trying to carry out an interim site visit, 1 to 2 site visits if possible. And we're constantly liaising with the contractor and the client throughout the project then with any queries and things that might arise. And when at the end of the project, once completed, we're carrying out a full snag of the project, making sure it's in line with SEAI standards and also building regulations. And we're gathering all of the paperwork from the contractor. So we're helping the contractor in relation to gathering that paperwork, telling them what they need to submit, and whatever we can do to help in that way. And then also arranging the post-works building energy rating assessment and claiming for the grants or submitting the grant claim. The case study here we have is Cormac Madden, which was a project done in 2016, County Dublin. It's a 1960s 4-bed semi-detached house. Deep retrofit measures at high level were air tightness, passive front door, various installation, ventilation, air to water heat pump, and solar PV. And that house went from a G to an A3 building energy rating. This is a quote there from Cormac Madden in relation to how he felt about the process. So his advice is to look at the house like a boat. You can't just fix one hole, the boat will still sink unless all of the holes are repaired. So that's the whole house retrofit model. And then he also mentioned that having had construction projects in the past that have been challenging, he found that Electric Ireland Superhomes service was invaluable, particularly in terms of sourcing the contractor and project managing the work, which made a potentially complicated and daunting task really easy. Thank you very much for your time and attention, and any questions you have, feel free to ask. I'm having a bit of trouble at the moment with the hearing on the other side, but feel free to email or call, and I can get back to you on any questions. Thank you very much.
Okay. Thanks a million, Shaun. That was great. Very, very informative. Just for information, everybody, tomorrow's webinar is insulation, presented by Ecological Building Systems, Joe Fitzgerald, and all the recordings will be sent, links will be sent out to you. If anybody has any questions, you can send them on either myself, Shaun, or Stevie. I just put that in the chat there because Zoom sometimes cuts off automatically. So no questions in the chat at the moment, so we can move on. Thanks a million, Shaun, and we'll see you all in the next webinar. Take care. I'll stop recording. See you all. Bye. Thanks.